Alright, yep. Now, number 4 on your study guide. You want to prove the Pythagorean identity, which there's 2 that I told you are the most important. This is one of them. The other one you also have to prove. That's the next part of number 4. So sine squared theta plus cosine squared theta is equal to 1. So you start with a triangle. There's a couple different ways to do this. You could work from the unit circle if you want to. I'm going to do it using a right triangle and Pythagorean theorem. So if that's theta, which is going to be the same theta for here, this is opposite of that. This is the hypotenuse, and that's the adjacent. Call it Pythagorean identity because it comes directly from the Pythagorean theorem. Pythagorean theorem tells me that, well, we usually say a squared plus b squared is c squared. Here we're working with different letters. The O and the A are the A and the B, and the C is the H. So when I do Pythag on this, I get O squared plus A squared equals H squared. Now, really there's not that much to this proof. I need to get the right side to be a 1, so I divide everything by H squared, all the terms individually. That can then be simplified to O over H squared plus A over H squared equals, well, A squared over H squared is just 1. Notice sine is O over H. Cosine of theta is equal to A over H. So here I have sine, and it's squared. So I get sine squared theta. Here I have cosine, A over H, this, and it's squared. So that gives me cosine squared theta, and it's equal to 1. And that's all. Make sure that you're doing it in this direction. Some people kind of want to start with sine squared, start here, and then work their way back up. That would be proving this, given that this is true. We want to start with this right here. Otherwise it's kind of like circular reasoning. We want to start with that, and then work our way through all these steps and get to that. Alright, look at that. I'm going to erase it. Pause it if you need to. The other one I wanted you to do was prove that sine theta over cosine theta was equal to tan theta. So what we're going to start here with is sine theta over cosine theta. And I'm going to show that it's tan theta. So first off, sine theta is O over H. Cosine theta is A over H. Tan theta is O over A. So this is kind of like a letter proof, I could call it. I'm going to take the functions and turn them into these letters here, and then show that I get O over A, which is tan. So sine theta over cosine theta is equal to O over H over A over H. I got to divide by a fraction, so it's really O over H times H over A. I multiply by the reciprocal of what I'm dividing by, that. Notice the H's cancel, gives me O over A. O over A is tan theta, so that's equal to tan theta. Notice I started with this and I ended with this, so I'm showing that they're true by doing this equals all the way up through. So that right there is a legitimate proof for that one. That's all.